All right, let me first get this into the slideshow. Okay, so you guys were learning about machines last unit, and you learned a lot of really good things. However, we've been talking about throughout the year here and there about heat. So we're going to learn a little bit specifically about heat because it's involved in almost every area of life. So I think it's important to learn this before the end of the year. And it's kind of fun to learn about too. All right. First thing to note is we've talked about theories in the past. Theories change. They change pretty often. So the theory that I'm going to teach you about heat actually is our newest and greatest theory. It's our current theory that we're going to learn about and that we teach, and it seems pretty accurate. However, we have thought that before, right? Actually, before the 18th century, what we believed about heat, and by we, I mean scientists, is that heat was invisible and it was weightless, but it was a fluid that was invisible and weightless, right? And so this fluid was able to flow from hot objects to cold objects, but we just couldn't see it. So at the time, they thought that that was really smart and really accurate, but we figured there's more to it than that. So I have a question for you. We know that theories about heat and theories about lots of other things are this way too. They've changed over and over again over the years. And the newest theory is the greatest theory, and it's true and it's right for us right now. But why is that? Why is it that we keep changing theories? Well, I think that this verse is really applicable in this. It's 1 Corinthians 13:12. It says, "For now we see only reflection, as in a mirror. Then we shall see face to face. Now I know in part, then I shall fully know, even as I am fully known." Okay, so what I take this to believe in this situation in science is people cannot know everything now, but someday they will. This verse directs people to have an attitude of humility because humans cannot see or understand everything that happened on Earth. Scientists strive to understand completely, but they may not be able to. When discussing scientific facts, it is important to maintain humility and not become adamant about knowledge gained through science. Okay? So I love science. I'm a science teacher. That's what I do, right? But at the same time, it's important to know that we can only understand so much, and the things that we think are true may not be the absolute truths. That all being said, it's still really important for us to learn about God's creation because, in my opinion, I think it's the best way we can worship Him with our minds, right? You know that verse, love the Lord your God with all your heart, soul, and mind? This is the way I like to worship Him with our minds, right? So we can worship Him the things as we learn more about His creation. Okay, let's jump into it. We have these three pictures. This could be hot water, hot coffee, hot tea, but you can see that it's hot, right? There's steam coming out of it. We have a book and ice cubes. So I'll pose the questions. Do any of these objects have heat? Okay. We're going to come back to this question as I teach you a little bit more, but start thinking about it, and after we go through the next slide, we'll come back to it. Okay? Okay, so what is heat? First, we need to remember kinetic energy, okay? Kinetic energy is the energy that exists in molecules of each of the substances. Okay, we learned all about chemistry. It's coming all back. We learned about molecules and energy in molecules. Remember, this is taking us back to learning about solids, liquids, and gases. I know that you guys know pretty well that solids have the least amount of energy and gases have the most amount of energy. Remember, solids, they're clearly not moving. You can look at a table and it's not moving. So the energy is very little. Then liquids have a little bit more energy and gases have the most amount of energy, and that's why they're moving all over the place. Okay, heat, the definition of heat is it measures the transfer of energy between the items of different temperatures. Okay, so there's a transfer of energy from item to item. Okay, and this also has to do with temperature. So we need to remember that heat is just a measurement. Okay, It's not really necessarily something to describe an object, it's a measurement. For example, if you say that you're a tall person, then it would mean that your length is higher than the average person. Okay, so similarly, if you say that an item has a lot of heat, then it means that the energy is transferring very quickly from that item to another item. Okay, now because we know about heat, we need to know about what temperature is. Okay, temperature is the measure of the average kinetic energy of the particles in an object. So we're going to try to measure the amount of energy in the particles that are moving. Okay, so they all kind of connect together. Temperature connects to heat, and heat is describing objects. So let's go back to this picture. Which items have heat? Okay, think about it. Come up with an answer in your mind. All right, the answer is yes, this cup of steaming water or tea, it has heat, but also the ice cubes have heat. Well, why do the ice cubes have heat? It's because the ice cubes are melting. Because the ice cubes are melting, there is energy being transferred into the ice cubes. Okay? Heat is always transferring from a warmer object to a cooler object. So the air is transferring its heat into the ice cubes. The cup of tea is transferring its heat into the air. Okay. Well, what about the book? I mean, isn't there a transfer of energy in the book? Well, you could probably assume, and that's what I'm doing, I'm assuming that the book has been in this library for a long time. Okay. So because of that, its temperature is now the same temperature as the air around it. So there's no current transfer of energy, so that means there is no heat. Okay? All right. So what do we know? So what do we want to know about heat? What is our theory? The theory is called the kinetic theory. That's kind of where we get our information about heat. Okay? But because atoms and molecules are too small to observe with our eyes, scientists actually observe the average behavior of a larger group of atoms. And this is what they found. The measure of the average kinetic energy of the atoms in an object is proportional to its temperature. And I forgot the G in here. I know some of you saw that. I'll fix it later. Okay, so the average kinetic energy of atoms in an object is proportional to its temperature. So we're talking about energy and temperature. Physical scientists describe the behavior of moving particles by using the kinetic theory. And this is a model developed to explain the states of matter according to the random movement of particles. Blah, 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 right? That's a lot of information. What does that actually mean? Okay, so basically, it means scientists have been able to connect our understanding of heat. So heat, remember, is the movement of particles, and temperature. So we're connecting heat and temperature. This is probably why we associate high heat with high temperatures. But in the scientific world, it is any object that is transferring energy, just like the ice cubes, right? The ice cubes have heat, even though they don't look hot. Okay, those two words are different in the science world. All right. So there are three assumptions based on the kinetic theory. So based on the theory, we as scientists, right? I'm not a scientist, but I say we in reference to science. We have developed three assumptions that we can assume based on what our theory is about kinetic energy. And here they are. All matter is made up of tiny particles that are in constant random motion. The second one is the speed of the particles directly correspond to the temperature. And the third one is at a given temperature, the total amount of kinetic energy of the colliding particles remains constant. Okay, those are the three things. Well, let's try to understand this a little bit more, and I think examples are probably the best way to do it. Okay, so first thing you need to know is heat always flows from warmer objects to colder objects, just like from the ice or from the air to the ice to melt the ice, or from the hot tea to the air. Okay, we're moving from warmer to colder. The first example is when you place your cold hand on someone's warm neck. I don't know if you guys have ever done that before, but the person's neck, they feel really cold, right? But then the person's hand starts to warm up. Okay, so you can probably imagine the heat is leaving the hand, or sorry, leaving the neck and moving into the hand, and it actually will continue. The transfer of heat will continue until both are the same temperature. Okay, and then this is the same as the picture in the background. Okay, if you have a fever, maybe you've done this, maybe you haven't, but some people will put cold cloths or cold packs on your head, and that's for the exact reason of heat transfer. Okay, it's moving the heat from your forehead, from your fever, into the cold pack. And it'll continue to do that until they're the same temperature, until the ice has melted, or so forth, okay? So it's important to know that the kinetic theory supports an understanding of heat, which is energy transferred between substances of different temperatures. Okay, I'm going to continue to emphasize that. Energy is transferred between substances of different temperatures. All right, now a couple of fun things. Because my favorite thing is the human body, so we can always relate something to the human body. Shivering. Why do we shiver? Why does the body shiver when you are cold? Okay, well, first thing you need to know is our internal body temperature. Some of you may know this already, but the average internal body temperature for humans is 98.6 degrees Fahrenheit, which in Celsius is 37 degrees, okay, because we use Celsius in science, but I know we all recognize Fahrenheit. So 98.6 degrees, if you were to take your temperature, that's what you would be. Well, that seems pretty warm, but your body needs to be warm for it to function, okay? So why does the body shiver then? Okay. Actually, I'm not ready for that yet. First, let me explain. Most of the time, the air temperature around you is colder than your body temperature. And you're constantly losing heat, losing energy through heat from your body to the air. Okay, that's why if you're cold and you're sitting next to a lot of people, or let's say it this way, if there's a small room with a lot of people, it gets really hot because everybody's transferring their body temperature into the air and it just increases the temperature of the room. Okay, but usually you lose heat very slow, and it's slow enough that your body can make up for it. And the way that your body makes up for it is it burns calories from the food you've eaten. Okay, so it generates, one of the reasons why your body burns food, or burns calories, I should say, is to warm your body up. And that's happening all day long. Well, when the air temperature gets too cold, and you start to lose heat much faster than you can warm up, your body starts to shiver. It's actually an involuntary thing. You can't make yourself do it. And it's little muscles that are moving, they're flexing and then releasing, flexing, releasing very quickly, okay? And the movement of those shivering muscles create kinetic energy. And this energy transfers to your cells throughout your body to warm you up, okay? So that's kind of interesting. And then a fun fact, I think this is really interesting as well. This place, people live, it looks really cold, it is really cold. This place is called, it's hard to pronounce that word, I would say Oymyakon, but that's probably not it. Oymyakon, it's Russian. So this is in Siberia, which is in Russia. This place is not the coldest place in the world, but it is the coldest place in the world where people actually live, okay? There's people living here on a daily basis. They live here all year long. And on average, in the winter, it gets to negative 96.16 degrees Fahrenheit, which is super cold, right? And that is also negative 71.2 degrees Celsius, okay? So almost negative 100 degrees. It's crazy. But then, here's another fun fact. This is, if anybody of you have driven this way, on your way to Death Valley, California, okay? You would think Arizona is much hotter, but there is an area of California that is hotter. There is one day that happened in 1913, so over 100 years ago, July 10th, 1913, in Death Valley, it reached a temperature of 57 degrees Celsius. Well, what is that in Fahrenheit? It's 134.6 degrees Fahrenheit. So in Arizona, we might like cry at getting over 120, but 134, that's pretty crazy. All right, guys, I hope you've enjoyed this and learned a little bit. Go ahead and, well, you should have been actually filling out your worksheet while we were going along, but go ahead and go back and fill in your worksheet and turn it in. All right, see you guys.